Okay, my name is Uwe. I'm present at the third international conference on ICT for development of Africa. The title is Cross-Lingual Textual Entailment Recognition using deep learning approach. Using the deep learning approach, the content that's including the introduction. The introduction part is including statements of problem, methodology, scope of study, objects of study, significance of study. Then the design and implementation, experimentation, evaluation, lastly conclusion, contribution, and recommendation. The natural language means the communication of the means of communication that human can be understand, read, and write. This speech and text languages are processed by a computer to communicate human beings with computer interface. This text process is known as natural language application or natural language processing. Natural language processing, I mean. The natural language processing developed due to the emergence of different NLP applications that including information retrieval, machine translation, text summarization, and textual entailment. Textual entailment is the application of NLP that exists the premise and hypothesis pairs of the texts and check whether the hypothesis differ from premise and vice versa. The textual entailment is either monolingual, cross-lingual, or multilingual. Monolingual textual entailment is the data sets that's prepared from the same language. However, the cross-lingual textual entailment it is prepared from different languages, that is premise from one language and the hypothesis from another language. Multilingual textual entailment that's building from multiple languages except a single line. The cross-lingual textual entailment is due to be improve the NLP applications and that is due to be improve the NLP applications like machine translation, cross-lingual similarity measure, cross-lingual information extraction, cross-lingual plagiarism detection, and the other cross-lingual scenarios. And this inferential relationship is either the forward, backward, bidirectional, neutral contradiction. There is example. This example is this premise text, the premise and the hypothesis. This first sentence is bidirectional entailment because the hypothesis differ from premise and the premise differ from the hypothesis, and the premise have equal features with the hypothesis. But for forward entailment, the premise have additional features than hypothesis. But the backward hypothesis have additional features than premises. The contradiction indicates that premise contradicts hypothesis and hypothesis contradicts the premises. The neither of the relationship is known as the neutral. The statements of the problem, different research have been studied on NLP to solve the natural language understanding problems. However, lower source language like Amharic not solved yet. To develop or the development of some cross-lingual models are not work for Amharic languages because Amharic language has the properties of structural, lexical, and semantical complexity. Script styles are different, morphological complexities also the other issue. Pre-processing of the text it is difficult, and the negative words it is linked with words, and different prepositions are linked with words, and the orders of subject, object, verbs are different. The prior studies are building atmosphere for classification. It's not 5 classification, and the information exchange and knowledge transfer between the two languages, especially for lower source American and source English, is not developed yet. So to solve such types of problems, we have proposed cross-lingual textual entailment recognition model using deep learning approach. The research question is a combination of excellent pre-trained model and BLSTM network improves the Amharic English cross-lingual textual entailment performance. Is the integration of lexical information with deep learning is improve the performance of the cross-lingual textual entailment prediction phase or the prediction. To what extent the proof model increase the performance of the cross-lingual textual entailment model? The objects of study, the main objects of this study is developing cross-lingual textual entailment models for Amharic English text. To develop this main object, the specific objectives are listed. That is the preparing the Amharic English cross-lingual data sets and text processing, also it is including, and identifying features that similar in different view in order to identify backward and bidirectional and forward features or relationships. The image translation, the buildings of models by using the BLSTM and ExcelNet. Lastly, it is for evaluate the performance of the models, these specific objects that help to or contribute to develop the general object. The significance of the study, that is to be improve the NLP applications, because different NLP applications that is understanding by the textual inference, for example, the cross-lingual scenario and multilingual scenario, even monolingual scenario also, it is a pair of texts that is identify one another based on the inferential or semantic similarities of the word, the sentences. And it is used to be contributed in the process of improving our source languages like Amharic into our source language like English. And the data sets it is collected from different domains, so this data set is available for different researchers. There's the scopes and limits of study. The models, that's the main objects of the models develop cross-lingual textual entailment model for Amharic English languages. So this is also, it is checking whether the premise that's infer from hypothesis or not, as well as this classified multi-way classification. However, the models not supporting multiple sentences in premises. If a premise has more than one sentence or two or more sentences, the models cannot be work. And the proverbs and poetry also not including from the model. Design and implementation, premise and hypothesis. There is a premise and the hypothesis texts. There's the premises and the hypothesis texts. So this is pre-processed. After pre-processed, the premise it is English transfer into Amharic. Then there's word embedding. The word embedding is used as the input for the sentence embedding. Sentence embedding is built from BLSTM and ExcelNet. The two model sets it is combined. Lastly, the pair of texts, premise and hypothesis, it is concatenated by the dot product, set reference and normal concatenation. From here we have tested by individually, but the model is outperformed better results than individual. Then there is a trained model. The trained model, this testing data is pre-processed, and from here it's translation. Then there's lexical score and similarity comparisons of between two texts. Then predicted if the relationship between two texts, that's premise and hypothesis, either forward, backward, bidirectional, contradictory, or neutral. The data collection, we have collected the data sets from Stanford Natural Language Inference Corpus and Excel Cross-Lingual Natural Language Inference Corpus. This corpus is available especially for the English data set. For Amharic data sets, we have gathered from different sources that are that's prepared for premise hypothesis pairs. In addition to this, we have prepared from different religious, political, and other data sets. So the combination to this Amharic and English data sets, it is available for cross-lingual textual entailment data sets for translation. For the dictionary based, we have tested using the dictionary based. We have used 23,000 so pair of dictionary that is accessed from these links. And for machine translation, we have used the 18,000 data sets. For language translation, machine translation under a single model to translate between two languages. We have used the attention-based neural network, that's by LSTM transformer. The combination of two models, it's outperforms the individual models, that's by LSTM transformer. We have used IBM5 model for alignment purpose. The dictionary-based, we have used the orthogonal transformation, that's the transformation of two similar words, that's based on the dictionary. This means the assigning similar vectors for similar words that check from the dictionary, that the sentence from the premise and the hypothesis are checked from the dictionary and assign the vector representation at the same time. This information is also used to the word embedding and sentence embedding to predict the result. The word embedding, we have used the fast text for sentence embedding, Entailment by LSTM. Both model sets bidirectional. The Entailment is also to be segment embedding, position embedding. That's the by LSTM that's available for the sequential information. For classification purpose, we have used the three model, beta amongst them. The MLP, multi perceptron, is better. When directly tested, SVMs outperform than other models, but when we adjusted the hyperparameters of multi-layer perceptron is outperformed than the other model. To identify direction of entailment, similarity view, or word overlap, and enneagram and concise similarity in different views also we have used. Lastly, we have used the word overlap because of the results similar except the score. So by using the word overlap, we have identified the lexical information or features of the each text in order to be identify the direction of the inferential relationship. There is the experiments conducted between the monolingual and cross-lingual. For monolingual is Amharic and cross-lingual is textual. That's translation based and dictionary based, but translation based is high score. Dictionary is low because of the shortage of the dictionary. The second experiment is this is by LSTM. The sample shows by LSTM the excellence outperforms the individual models. That is 89.92% of training accuracy, and the last classification accuracy is 86.89%. The third experiment is by using a lexical information and without lexical information. With lexical information is outperform high score. Amongst them we have used 0.5. For this purpose we have used the 0.5 threshold values. Without threshold values and threshold values, with threshold values, especially 0.5 is outperformed than others. The discussion of the inferential relationship, we have used the combination of LSTM and Entailment to improve the models. So these combination models outperforming than the by LSTM by 5.56. Then Entailment the 6.73 and outperformed the by LSTM from the 8.88%. Conclusion: cross-lingual textual entailment is an application of natural language processing that's used to be building the cross-lingual textual entailment. So it is check the hypothesis is infer from the premise and premise infer from hypothesis or not. We have developed multi-way classification. This multi-way classification is building after 5 main tasks that's completed. That is preparation, translation, embedding, and classification. So we have used the IBM5 for alignment purpose, for translation, and totally you have collected totals of 11,714 data sets. By using this data set and 10 imports, we have obtained the high accuracy than the individual and low data sets. But there is an issue. This issue is our system is not supporting multi-sentences. The contribution, we have organized cross-lingual Amharic English data sets. It is the first. For transpose, we have used the transformer and by LSTM models combined, and this model is outperformed the other models. We have developed multi-way classification, and we have used dictionary-based cross-lingual textual entailment using a dictionary, and we have integrated lexical information with the deep learning to improve the and to identify the directions of the entailment. For recommendation, develop multi-sentence entailment, that's premises have multiple sentence or the hypothesis with the existence of the multiple sentences. And we have recommended to including the proverbs and word disambiguation for sentence in order to increase the performance and generating the textual entailments and the predict the inferential relationship, as well as assigning genres for the each sentence pairs. Thank you. I have finished from here.